Al-Dareyn Modern School hoyga aqoonta.
Hello students, welcome to physics class form 2 chapter 6 force. In this lesson 4 we are going to cover the topics moment and levers and some problems on moment and levers. Let's start the class. Levers. What is the levers and what are this what kind of diagram is this, and everything we are going to learn here. Forces can move objects by turning them around a pivot or a fulcrum. Have a look here. This is called a pivot or a fulcrum. When you applied a force over here and you place and load here, then it starts moving, and these two parts are going to move or balance or unbalance because of force and because of the load. If the load is more, it goes down. If the load is less than the force, it moves up. So this type of machinery is called lever, right? Now forces can move objects. What forces? This is downward force, this is upward force. Can move objects, turning them from here. It is turning. That part is called pivot or fulcrum. A long bar that pivots is called lever. Means this is a bar which is going to be pivot is called lever. This is called lever. Right. When you push down one side, you are applying force. This is the force that you are applying. You are pushing down. The object on other end, that is the load, moves up. Right? You are applying more force. Right? Next, using a lever magnifies the force and makes objects easier to move. Right? We have seen in the schools or in the playgrounds, you have seen seesaws up and down according to the weights you used to play. Right? That is nothing but same technology, same method here, same device, same experiment. Right? Next. Now we have types of levers. Types of levers. That is, first we can see first order. Here we have types of levers. The first order. What is first order? In this type of lever, the pivot or fulcrum is between the effort and the load. As in the simple crowbar. Look here. This is a crowbar here. See here. This is the load and this is the effort. If the pivot is in between the load and effort, this is the first order of lever. What is the first order of lever? If the pivot is in between the load and the effort. In between the load and effort, and that is called the first order. What is that? The lever, the point, pivot or fulcrum is in between the effort and the load. Right? Right. Fine. Next, second order. What is second order? If you look over this picture, so pivot is left side, the load is in middle, right? So this kind of order is called second order. What is it? Load is in between the pivot and the effort. This kind of machines, this kind of devices where we apply is called second order. In this type of lever, the load is between the effort and the pivot or fulcrum, as in the wheelbarrow. Right? Next. Next we have third order. Now see here, what is in middle? Effort is in middle. How much effort we are applying, right? If the effort is in middle, in between the pivot and the load, then that type of lever is called third order lever. See, lever, effort is between the load and the pivot, as in the pair of tweezers, right? To pick something, small objects, right? That is called third order, right? Next, what is moments? The moment or turning effect. Moment or turning effect can be calculated using the following equation, that is moment equals to force times perpendicular distance from pivot. Force times perpendicular distance means, suppose we have a door knob, we push or we pull, means what happens, the door, we are applying the force and the door is moving perpendicular to our right. In this case we can call this is an turning effect, or we can also call moment. We have already learned this topic in the form 1 also, right? So what is that moment? Moment is nothing but force times perpendicular distance from the pivot, right, from pivot. That will be in the measurement centimeters or meters. It will be not in kilometers, because the door will be in meters or centimeters. Whatever the objects we open or close which are perpendicular, that will be only in the meters or centimeters, not more than 1 meter, right? Fine. So we can also see moment is nothing but, we can also draw in the diagrammatic method, force times displacement. Moments are measured in the Newton centimeter or Newton meters. Why here force units is Newton, distance meters, or no, newtons or centimeters. You can take any type of any one unit according to the problems, according to the right. Next, here we have a calculate the moment. Look here, a small animal, two animals are here, like goat and the fox. They are standing on a lever at one side, whose force is applied downwards. The force is 5 newtons, right? Means the force applied, this is effort that we applied, that is how much? 5 newtons. So how much distance is the lever? 10 centimeters. Distance is how much? 10 centimeters, right? And see here, what is this? This is nothing but the load, right? What is moment? What is the formula for the moment? Moment equals to force times distance. Force is how much? 5. Distance is how much? 10. So 50, right? Newton meters. If it is centimeters, Newton centimeters. Fine, right. Next, in the same way, force he has given here 5 newtons, and the distance how much? 5 centimeters, and this is the pivot and this is the load, right? So how much? Now according to to calculate the moment, the formula, as we know the formula for the moment, m is equals to, right? So we can take as a moment formula can be taken as force times distance. So we can just substitute the values. 5 times 5, 25 Newton centimeters. Fine, right. Next, in the same way, we have already did the same problem, but the force was here. The force is 10 newtons, distance is 10 centimeters, force times distance 10 times 10, 100 Newton centimeters. Fine, right. Next, now look here. Here we don't know the force, how much it is applying towards downwards, question mark, but we know the distance, right? And we need to, he has given the moment is 500 newtons. Means what we need to find? We need to find the force. Basic formula for the moment is force times distance, but he is asking force. Force is equals to moments by distance. Moment is how much? 500 Newton meter. Distance is how much? 2 meters. Meters cancels. 2 to 4, 2 5 10, right? 250 half. So 250 newtons we need to apply here. How much? 250 newtons of force. Fine, right. Next, in the same way here, what is the topic here? Balanced moments. Balanced moments. When are they going to balance? LHS and RHS, when they are going to balance, when they have the equal weights, right? Look, here are the two types of dinosaurs. Here we have left moment and the right moment. Here he has given the left moment is 100 Newton meters, right? And the right moment is 100 Newton moments. First we shall find this part and then we shall find this point and then equalize, are they balanced or not. First let's know how much is this, right? Left moment is how much? M is equals to force times displacement. Moment is how much? 100 Newton meters. Force is how much? 10 times 10 means how much? 100. Means 100 equals to 100, right? Fine. Now come here, same values are same, means both LHS is equals to RHS. Means left side moment is equals to right side moment. The distances are same, forces are same, and the moments are same. It means both are going to be balanced. This kind of scenario is called balance moments. Now look here. In this balance, is this balance moment? No, it is not the balance moment. See here, the left moment is 100 Newton meters, right moment is 70. Both are not equal. Both are not equal. Is it 100 equals to 70? No, it is not. So this is called unbalanced. If the moments are not equal, if they don't have the equal magnitude, then we can say that they are unbalanced. This kind of scenario is called unbalanced. See, the distances also change, right? Fine. Even here, now check here. Here we have 100 Newton meters. Here we have 200 Newton meters. 20 newtons, 10, 10, 10. Is it balanced? We need to check. How we need to balance? How we have to balance this? First find the LHS and first find this moment. How much is there? 10 times 10. How much here? 10 times 20. So here first we can find M is equals to 10 newtons times 10. How much? 100. In the same way, right side, how much is the newtons? Force is how much? 20 times 100 equals 200, right? So it is an unbalance. So this is, we can have also 100 nanometer and 100 nanometer. Next we have an principle of moments. For an object to be an equilibrium, any object to be an equilibrium, we can also call it balance, the following two conditions must be true. How many conditions we have? 1 and 2. 1 and 2. These two conditions must be satisfied so that the moment is going to be balanced. What are they? The total upward force equals to the total downward force. Means upward force should be equals to the downward force, then only we can balance, equal weight. Next, sum of the anti-clockwise moment is equals to sum of the clockwise moment. Means how much moment it is going towards that side and how much moment towards this side, it should be equal. Then only we can say that, means moment equals to force times displacement, right? And here also moment equals to force times displacement. This which is towards clockwise, this which is towards anti-clockwise, both should be equal. Then only we can say they are balanced, or we can call as an equilibrium. Right? Here we have some conditions, some examples, some samples of the balance or a non-balance. We have to check over it by calculating. Calculate the load on each side and say if the level is balanced. Level is balanced. Will move clockwise or will move anti-clockwise. We have to check whether it is moving clockwise moving or anti-clockwise or balance. Or is it moving towards this side, or it is moving towards this side, or it is balanced. That we are going to check by this. First, number 1. See here, 10 times 1. 10 times 1, LHS, right? How much we will get? 10. In the same way, 5 times 2. How much you will get? 10. It means both are same, equal, means it is going towards that side. The momentum is 10 and the momentum is 10. Both are equal. So this is balanced. Right? Now here we look here. Second, 20 times 12. How much you will get? 240. Right? 240 towards clockwise. And what about this side? 15 times 8. 120. 120 towards this side. Means, now is it balanced? No. Will move. How it moves? See here. It moves towards this side. Or this side. Here the momentum is more, right? So it starts moving this side. So we can call as anti-clockwise direction. Here 240, here 120. It is less, moves up, right? Means it goes like this. In the same way, in the third one, 20 times 8, 160. 15 times 11. So how much? 165. So it will go, this is very less, means it will move toward the side. It goes down, it goes up, means it will move in this way. That is clockwise. Right? Next, this is moves like this clockwise and this is moves in anti-clockwise. Right? Now from here, 8 times 2, 16. 5 times 3, 15, which is less, this is less. So it will move, means it will move in an, this is called clock direction, anti-clockwise direction. Fine? Right. Now, small question here. Why is it easier to open a tin, this is a tin of paint with a screwdriver than with your bare hands? Why we use this screwdriver why we are not using our bare hands? It is very difficult to use with bare hands, right? So why we use this screw? This here, the screwdriver acts as a first order lever. What is that? First order lever means the point fulcrum is at the point where the effort is applied on the lid here, right? By using a screwdriver, you increase the distance. You increase the distance at which the effort is applied. Effort we are going to apply when the distance is increased. You can apply very less effort. So this increase the moment, making it easier to open the lid, right? Many times we use this kind of levers in our real life to open the close, right? Fine. Thank you.